In this video, we'll cover the topics that are covered in class on week 1, that's September 8th through September 11th of 2020. That'll include Lesson 1-1 examples 1 through 4. With each example, I'll walk through the solution and hopefully answer any questions you might have. Let's begin. With example 1, we're looking for the domain and the range of this function x squared minus 3. They've already graphed it for us. Remember, the domain is the x values in which the function occurs. So for this one, we can note that the x values are used all the way from the beginning to the end. This parabola would never end, so we would say it'd be all real numbers. The range is the y values that are used by the function. How low or how high does it go? The lowest number it uses is -3, and it appears to be going to infinity. So we would say from -3 to infinity. We can practice our set notation or our interval notation. Our domain would be all real numbers. That'd be indicated by -infinity, positive infinity with soft parentheses. Our set notation would be the ellipses with x, where -infinity is less than x is less than infinity. For our range, we would begin with our interval notation as -3, and it can include -3 to infinity with the soft bracket. And our set notation is y would go from -3 is less than or equal to y, which is less than infinity. We can rewrite the function here just as a little reminder, x squared minus 3. How do we know the function has no maximum? Again, that's indicated here by these arrows, so you could write that in this right there. There'll be some videos that you may watch on set notation or interval notation, and if you haven't already or you don't quite understand it, be sure you look that up to fill in your notes. Let's practice a couple. For interval notation, that has the brackets or the parentheses, we see bracket 3, 4 bracket. That means between and including 3 to 4. Now that's not the only way to write it, but starting at 3 and ending at 4, including those numbers. Our set notation, we start at 3, it'll be less than or equal to x is less than or equal to 4. Those gator symbols or inequalities can be tricky, but I like to think if it's between two numbers, you put your lower number first and your higher number second, and your x in between those values. Notice I have the underline to indicate that 3 and 4 can be a solution, as is noted by these hard brackets here. Let's try one more. Let's come down here. All real numbers greater than or equal to 3. So that would be like starting at 3 and going above that. So I could start with 3 with a hard bracket because 3, it could be equal to 3, infinity, because all real numbers that are bigger than it, and a soft bracket because all infinities have the parenthesis. For my set notation, I would say x is my variable, and I want x to be greater than or equal to 3. You'll want to fill out the rest of the table, and you can find the PDF answer key to be sure all of your answers are correct for this page. For example 1, part B, we have an air tanker flying over and dropping water on a forest fire. It's important to note that the picture actually includes a lot of information, so we need to look at that first. The tank holds 8,000 gallons of water, as we see here. It's also releasing 400 gallons per second to put out the fire. They're asking us for the domain and range of a function that represents a volume of water that they can drop in x seconds. We don't have a graph or an equation here, so we need to think about domain and range for what they represent. Domain is all the x values. So for our domain, since it mentioned that x is seconds, we are going to say, well, how long is the airplane flying? You might say the picture doesn't tell me that, but let's think about it. They have 8,000 gallons of water to be released. And if they release 8,000 gallons, they're going to do it over time, only 400 gallons per second. So we take that 8,000 gallons and divide it by 400 gallons per second. We'll see how many seconds it's going to take to release those 8,000 gallons. And we get 20. That means our domain will have started at 0 seconds, or the time would have been 0, and gone all the way up to 20 seconds. There's our interval notation. Our set notation would be as follows. Now, we could also say, we should maybe think of it, we don't want to include anything negative. We could restrict our negative, or maybe I should write it like this. 0 is less than or equal to x is less than or equal to 20. Now, for our range, since x was time, the other variable we're dealing with is the water. So our y, or our range values, will be concerned with how much water there is. Negative water wouldn't make sense. So we're going to start with 0, no water has been released, up to the 8,000 that they're going to release. Again, in set builder notation, that's what we would have. We're going to practice our interval and set builder notation with graphs of functions. The absolute value of x minus 4 here on part A, again, graph on Desmos or TI, and if you're not sure how, make sure you find that video on how to graph using either one of those programs. I've graphed it here, and I can see the picture has my v starting at 4. My domain will be all the set of x values. So as I travel along and I see it seems to be going on forever, so my domain is going to be all x values. That would be from negative infinity to positive infinity. And for my set notation, they often will write all real, because all real numbers will work. For our range, that's the y values. Well, it seems to have stopped here. This is how low it will go. So that y value, be careful, it's not 4, it's going to be 0. It's the low value of 0, and it will shoot off into infinity. So we would include 0 with our hard bracket and go to infinity. With our set notation, 0 is less than or equal to x is less than infinity. On our second example, we would graph it again, and here is an example graph. I'll move that over. So for our domain and our range, our domain is all the x values. Again, now this isn't always the case, but with a lot of these parabolas and absolute value, your domain is going to be the same. When I scan, I know you can't see the graph here, but it will keep going, and eventually it would get there. So again, all real numbers, negative infinity to positive infinity for our domain. And our range is the y values that are used. So I'm going to see the highest it appears to be going here is about 5. So I would say it's going from negative infinity. You always want the lower number first. So it's shooting down here. We can see it's going really low. Negative infinity up until the value of 5 and including 5. Note that if you're in Desmos and you can actually click on that, you could get that exact value there. So my set builder notation would be from negative infinity to 5. In example 2, we have a car on a journey that's modeled by this equation, and they even graphed it for us over here. So we'll use that to answer our questions. Looking for x-intercepts and y-intercepts of the graph and what it represents. It's important to read the titles on the side of your graph, as always. But let's look at our x-intercept. Remember, the x-axis is the one that is flat. The y-axis is the vertical axis. Now, they do have them labeled as m and g, most likely there for the m for miles and g for gallons. So being that I crossed right here, my x-intercept, or m-intercept if you will be 320, 0. That means 320, we have miles there. So what would that represent in this situation? Well, that's how far we're going to travel on one tank of gas. So 320 miles for a full tank of gas. Now let's look for the y-intercept. We have 16. Note that with the y-intercept, we would want to put our y value second. So I will have 0, 16, and that would be representing something about gallons. Well, that's probably how full my tank is, or how much capacity my tank has. So my max capacity, or a full tank for my car, is 16 gallons. The second part of example 2 is dealing with the absolute value of x minus 3. Again, you may graph that wherever you choose. I'll have a little snippet pop up here, and there it is. My x-intercept, if I look closely here, be careful of my scale, -2, -3, -4. We'd like you to write it in coordinate form, so my x-intercept, we'll label that here, would be -3, 0. But note that there's also another one with absolute values, so that would be 3, 0. My y-intercept is where it crosses the y-axis, and down here, -3. Remember, the x value comes first of 0, the y value comes second of -3. You can find a video on finding x and y intercepts algebraically and put any notes you might have here. For now, we're just going to try it with this number 2. To find any y-intercept, I'm going to start with y-intercept, you would make your x value be 0. So for my y-intercept, I would have y equals 4 minus 0 squared. 0 squared makes 0, so y would be 4. My y-intercept would be x is 0, y is 4. Now, there's a reason I did my y-intercept first, because it was easier. My x-intercepts are a little bit trickier, and it's going to require you remember some of your factoring, or maybe some guess and check visualization. Is it always okay to graph it and give it a check? For sure, but we're trying to work on finding them algebraically, so I'll do that here. When you're finding the x-intercepts, you want to make your y value be 0. So in this case, I would have 0 equals 4 minus x squared. We'd be thinking, what number can I plug into x, square it, and subtract it from 4 and get 0? You might think 2, which that is one of them. We'll have 2, 0. But another one could be -2, because remember, a negative times a negative is a positive, so it would be a positive 4. And you subtract that, you would get 0. But to take you back to the olden days of how you might solve this algebraically, you would need to factor 2 minus x and 2 plus x and set it equal to 0. You'd be asking yourself then, what number plus 2 would make 0? Well, that'd be -2. And 2 take away what number would be 0? There'd be 2. So factoring came in handy when I was dealing with this difference of squares or this quadratic, but I was also able to mentally think about what number squared subtracted from 4 would be 0.